Hello everyone, we are team number 4 and myself Lokesh Kumar Alla and my teammate is Tala Nikita, and today we present our end-to-end MLOps project on predicting model metro interstate traffic volume. The goal of this project was not just to build a model but to build a complete production grade automated pipeline. We used the UCI Metro interstate dataset, which contains hourly traffic data along with weather features like temperature, rain, and cloud cover. And our objective was to predict traffic volume hours in advance to help city planners. Here is our architecture. We just start with data cleaning, move to AutoML for model selection, use AWS and MLflow for experiment tracking, and finally we deploy the champion model using Fast API. So let's just dive into the pipeline. First, data preparation. Since this is the time series data, random splitting would cheat. So we just implemented a strict chronological order split. The first 35% is for training, and the next 35% is for validation, and the final 30% is for testing to simulate future data. And we also handled missing values and outliers, for example like removing physically impossible temperature of 0 Kelvin. After cleaning, we ran H2O AutoML to analyze the best algorithm families. H2O identified that gradient boosting machine GBM were the top performer. With this insight, I'll pass it to Tala Nikita to explain how we trained and tracked our specified model.
Thanks, Lokesh. My name is Nikita. Based on the AutoML results, we developed standalone training scripts for three models. The three models are a light GBM, a random forest, and a linear regression model. The critical part here is our remote infrastructure. We are not tracking locally. As you can see here, we set up an MLflow tracking server on the AWS EC2 instance, and then here in the MLflow dashboard running on our AWS IP, you can see all our experiments. For the GBM model, we logged everything, hyperparameters like learning rate, matrices like RMSE, and even artifacts also. We achieved a test RMSE which is excellent compared to baseline of 1500, and then we registered this model in the MLflow model registry and promoted it to the production. And for the deployment, we built a fast API application that automatically loads the production and model from MLflow. This means if we retrain and update the registry, the API stays current. And here is our live API documentation. Let's test the prediction for this live API documentation, and there we go. It predicts a traffic volume of 4,850 vehicles with an immediate response. And then the API also includes pandemic validation to ensure that if someone sends bad data like a steering instead of a number, it catches the error before crashing the model. And now finally, no MLOps project is complete without monitoring. We simulate a production scenario using the final 30% of our data from 2016 to 2018, and we compare it to against our training period. And now we are showing a drift report. This is our drift report using evidently a we generated this draft report. You can see that here temperature and weather description.
To wrap up, we have successfully built a robust data pipeline, and we have set up remote tracking on AWS EC2 and S3, as you can see, and we have optimized a champion GBM model and deployed a scalable API also, and implemented drift monitoring as required. So all our code documentation, and reports are available in the GitHub repository. Thank you so much for everyone watching. Thank you.